Welcome to my channel, DNA.12 Education. Hello students, welcome again to my channel, DNA.12 Education. Today we have a topic in mathematics, differentiation. Mathematics A-Level for Cambridge International, differentiation part 1. Okay students, directly we go to this topic. We're going to understand about the differentiation, in mathematics. Students, differentiation is a method to find the gradient of a curve. Once again, differentiation is a method to find the gradient of a curve. Mathematics A-Level, differentiation part 1. Students, before we go to differentiation topic, the first is we have to understand first about limit. What is limit in mathematics? Okay, students, to make sure you understand about this mathematics, especially in limits, the first time we have to understand how to analyze a graph or to understand about the graph. Let's say this graph is y equal fx. Okay, this function, we call this function y equal fx. Okay, is it clear to everyone? Okay, on this function, let's say this one is point A. Let's say this point is A. This point has a tangent line. This point has a tangent line. Okay. Is it clear to everyone? Okay, next. These points consist of x-axis and y-axis. I mean, x and y coordinates. This point we call point B. Automatically, B has tangent line as well. Okay, as I mentioned before, this point A has coordinate x and y. We name this one XO. XO is the coordinate of A respect to FXO. Once again, point A has a coordinate XO to x-axis and automatically FXO to the y-axis. And point B as well, it has x1 as a coordinate to x and fx1 to y-axis. So the coordinate of B is x1 and fx1. Fxo, sometimes we call that as yo. And for fx1, we call it as y1. So fxo equals yo and fx1 equals to y1. Actually, they are same. Okay. When xo translated to x1 as h step, let's say the distance is h. So we can assume that x1 is xo plus h. x1 equal xo plus h. Is it clear to everyone? So it means xo is translated by h step to x1, or xo is moved by h step to x1. So distance xo to x1 is h. So that's why we call x1 is xo plus h. Right, everyone? Okay, next. So because x1 is xo plus h, so automatically the intersection to y-axis is fxo plus h, right? That's the relation of x-axis to y-axis, right? That's very easy, right? Okay, students. Okay. Now we have the coordinate of A is xo, comma fxo, and the coordinate of B is xo plus h, comma fxo plus h. Right? That's very clear. So coordinate A has coordinate as xo, comma fxo, and point B xo plus h, comma fxo plus h. That's very easy, right? Slope of the tangent line. Now, what is the information we will find from the description of this graph? The first is slope of the tangent line. Students, what is tangent line? As I mentioned before, the tangent line is the gradient actually, right? Okay, look at this graph. Once again, students. This is the tangent line, right? Look at the red color. The red line, we call that slope of the tangent line. Let's say this one is delta y, and this one is delta x, right? Once again. Okay, this one is delta y as a vertical line, and for the horizontal line is delta x. Is it clear to you? So slope of the tangent line we can define as m tangent equal f in the bracket xo plus h minus fxo over xo plus h minus xo. Or based on the drawing on the screen, we can define that m tangent is delta y over delta x, right? We call this m tangent. Very easy and very clear. And we can simplify this tangent, m tangent equal fxo plus h minus fxo over h. Is it clear to you how to find h? Okay, students, it's very easy. Okay, xo and XO will be cancelled, right? So we can simplify this one as H, right? As a denominator. So we can simplify that M tangent equal Fxo plus H minus Fxo over H. Is it clear too? Delta Y over delta X. Very easy, right? That's the tangent or the gradient. Okay, students, we can continue. Point B is quite far away than A. So it's one, not point A, but point B. Okay, point B is one, right? Is quite far away than A. Point B is quite far away than A. When point B is brought closer to A, so it means x1 minus xo limits to 0. Once again, x1 minus xo limits to 0. Or h limits to 0. Or h limits to 0. Okay, next. The gradient will be closer to 0. Once again, when point B is brought closer to A, that means the gradient will be closer to 0. Mathematically, dy over dx equal limit h to 0 of the function xo plus h minus fxo over h. In mathematics, dy over dx equal limit h to 0, limit h limit to 0, fxo plus h minus fxo over h, we call this term as derivative. So differentiation is called as dy over dx equal limit h to 0 of the function xo plus h minus function xo over h. Dy over dx sometimes is called as derivative. This is the first principle of differentiation. Okay, students, the first principle of differentiation. Differentiation is the process that we use to find the gradient of a point on the curve. To understand this better, we call that to find the gradient or slope of a straight line, we simply define the change in y by the change in x. dy over dx equal limit h to 0 of the function x plus h minus fx over h. Very clear, right? Once again, dy over dx equal limit h to 0 of the function fx plus h minus fx over h. Okay, students, how to apply this differentiation equation? Okay, Look at this sample. Differentiate y equal x squared by using the first principle. Y equal x squared. dy over dx equal limit h to 0 of the function x plus h minus fx over h. So mean dy over dx equal limit h to 0 of x plus h squared minus x squared over h. Next, we will expand this one, right? You should remember a plus b squared equal a squared plus 2ab plus b squared. Do you still remember this formula? Right? So, x plus h squared, it will be x squared plus 2xh plus h squared. Right? Next. So dy over dx equal limit h to 0 of x squared plus 2xh plus h squared minus x squared over h, right? X squared and minus x squared are cancelled. So it means only 2xh or plus h squared over h left. Okay, students, we can simplify this function. It will be dy over dx equal limit h to 0 of 2x plus h. And then substitute h by x, h equals 0. You can substitute this function, by h equals 0 here. So it means 2x plus 0 left. Right? So it means dy over dx equal 2x. Very easy, right? Okay, students, go to the next example. Differentiate y equal x squared plus 2x plus 1 by using the first principle. As we know that the function dy over dx equal limit h to 0 of the function fx plus h minus fx over h. That's very clear, the first principle. Okay, y equal x squared plus 2x plus 1. So means dy over dx equal limit h to 0 of the function x plus h squared plus 2 opens the bracket x plus h in the bracket plus 1, and then minus x squared plus 2x plus 1 over 8. Is it clear to everyone? Okay, this is the function of x plus h, right? When we have fx is x squared plus 2x plus 1, and then how to modify this function to the x plus h, so it means you just copy this function. It will be x plus h squared, right? Plus 2x plus h, and then plus 1. Very easy, right? So you just copy the function and follow this formula. Limit h to 0 of fx plus h minus fx over h. Okay, next. So, dy over dx equal limit h to 0, and then you have to expand this one, right? Okay, this one, you should remember this one. So, x squared plus 2xh plus h squared, right? So it means this one. You got it, right? This one, right? Okay, next. We got this function already. So what's next? We can simplify by canceling the same term. Cancel. X squared and minus x squared. 2x and minus 2x. Cancel again. And the last is 1, 2 minus 1. Cancel again. So automatically dy over dx equal limit h to 0 of to x h plus h squared plus 2h over h. We can simplify by h, right? So dy over dx equal limit h to 0 as 2x plus h plus 2. Is it clear to everyone? I will show you how to process. Okay. I will distribute this function 2x plus h plus 2, right? And then over h. Good. Then cancel, right? You can cancel this one. Cancel. Cancel. So that's why we got this one, right? Good too? Next. Now we're going to insert h equals 0 to this function. You can substitute h with h equals 0. And automatically, we got dy over dx equal 2x plus 0 plus 2. Finally, dy over dx equal 2x plus 2. That's the answer of differentiate y equal x squared plus 2x plus 1 by using the first principle. Is it clear to you, students? Very easy, right? Okay, students, we go to the next step. Differentiation formula, the derivative. The differentiation formula, we call that as derivative. Let y equal ax to the power of n. Again, y equal a times x to the power of n. When n is a real number and a is not 0. dy over dx equal y accent equal n times a times x to the power n minus 1. That's a derivative of the differentiation formula. Okay, differentiation formula as a derivative of y equal a times x to the power of n is dy over dx equal y accent equal n times a times x to the power n minus 1. Very easy, okay? So it means we have to multiply the coefficient a with n, and then the power will be minus 1. That's the short function, right? Okay, look at the sample. Differentiate y equal x squared by using formula. So y equal x squared, dy over dx equal y accent equal 2 times 1 times x to the power 2 minus 1. Okay, I will show you the process, how to find this. Okay, the first is 2, yeah, as the power will be times to the coefficient. The coefficient here is 1, right? Because 1 is a number. 2 times 1 is 1. 2 times 1, right? And then times x, the power will be minus, okay? Subtracted by 1. 1. That's the formula. Let's see everyone. Okay. So finally, we'll find that dy over dx equal y accent is 2x. 2 times 1 is 2. And then x power 2 minus 1 is x to the power of 1. So that's why it's 1x. power 1. So dy over dx equal y accent equal 2x. Easy, right? Okay, to make this one clear, how to differentiate of the function, or how to apply the derivative methods, we go to the next example. Okay, so then differentiate y equal x squared plus 2x plus 1 by using the formula. Okay, students, y equal x squared plus 2x plus 1. dy over dx is y accent equal to x to the power 2 minus 1 plus 2 times x to the power 1 minus 1 plus 0. How come? Okay, I want to show the percents. I think this one x squared and this one is clear, right? So you just times the coefficient by the power, right here. And then you'll find that 2x, and then the power will be minus 1. So 2x to the power 2 is 1. And this one, 2x. Actually, the power is 1, right? The power is 1, okay? So 1 will be times to 2, okay? 1 will be multiplied to 2, and we got this one 2, right? And then the power minus 1. 1 minus 1. Okay? We got this one clear. So why 1, the differentiation or differentiation of 1 equal 0. I want to share the percents. 1 actually equal 1x to the power of 0. Can you agree with me, right? Okay. Now we're going to differentiate this term. Okay, 1. 0 times 1 is 0, right? 1, 0. Is it clear? And then that means 0 times x, and then don't forget this, the formula, the power will be minus 1, right? So we can simplify this one, 0 times x to the power minus 1. You should remember 0 times everything is 0. So that's why this function is 0. Is it clear to you how to differentiate the function? Very easy, right? Okay, next. Okay. So we can simplify this one is y accent equal to x plus 2, right? Because x to the power 1 minus 1 is x to the power of 0, right? X to the power 0 is 1. 1 times 2, 1 times 2 is 2, right? 1. Very clear, right? Okay. So, dy over dx or equal y accent is 2x plus 2. Very clear. Okay. So then something to remember. When x equal constant, so dy over dx equal y accent equal 0. Once again, y equal constant, so dy over dx equal y accent equal 0. And one more, something to remember is, when y equal constant x, so dy over dx equal constant. Okay, is it clear? For example, this one. Y equal 5x. So dy over dx equal 5. That's very easy. Okay, students? Okay, next. The next example, this one. Differentiate y equal x to the power 4 plus 3x plus root of x plus 7. Y equal x to the power 4 plus 3x plus root of x plus 7. Okay, students, that's our job. Y equal x to the power 4 plus 3x plus x to the power of a half. Differentiate one. It's 1 root of x equal to the x is to the power of half, right? You should remember about the indices, right? This is the indices, right? So root x is x to the power of half. Let's say. Okay? So y equal x to the power 4 plus 3x plus x to the power of half plus 7. Next, dy over dx equal y accent equal 4 times x to the power of 4 minus 1 plus 3 times x to the power 1 minus 1 and plus a half times x to the power of half minus 1 plus 0. Okay, I will show you the process. This one, the process. Number 1. So this one is, I think it's very clear, right? Okay, 4 times 1 and then the power will be minus 1, very clear. And this one 3x, and this one is very clear. Yeah, this is the power 3x to the power of 1, right? So that's why this one times 1 times 3 is 3. And then don't forget to subtract it by minus 1. Yeah, so the x to the power of 1 minus 1, you got this one, right? Okay, this is the unit 1, x to the power of half. And it will be this one, right? So half times x to the power a half minus 1. Okay, very easy, right? And then the differentiation of 7 is 0. This one. Okay, very clear. Is it? Okay, good. Next, today. Okay, next. So we can simplify dy over dx equal y accent equal 4x cubed plus 3 plus a half x to the power minus a half. So we can simplify again dy over dx equal y accent equal 4x to the power 3 plus 3 plus a half times 1 over x to the power half. Please remember this one? Okay, I think this is very easy, right? Okay, students? This one is very easy actually. So this one. X to the power minus half. That's equal to 1 over x power half. Do you remember this indices? Okay, do you remember this one? 1 power minus 3 equal to 1 over a to the power 3. You remember this one? Okay, let's remember x to the power minus 2, it will be equal to 1 over x to the positive 2. Right? Okay, good. So that's why x to the power minus half, x to the power minus a half, it will be this one. Right? Right? Very easy, right? Good. Next. So it means we can continue this function. We can simplify this function. dy over dx equal y accent equal 4x cubed plus 3 plus 1 over 2 root of x. Once again, 4x to the power 3 plus 3 plus 1 over 2 root of x. That's the answer. That's very clear, right? So what do you think about the differentiation? Is it easy or difficult? Yes, I agree with you. That's very easy. Yeah, once again, in mathematics, differentiation sometimes called by derivative. Other students, to make sure everything's clear, friends, this is the exercises about differentiation and derivative. Good luck.